Okay, so next thing is using the methods that we've defined here to find quartiles and percentiles in the data set. These are just kind of like markers in the data set, measures of position. We saw some of this back in section 2.5. Quartiles, the main thing you want to remember about quartiles is they divide the data up into quarters. So when we talk about this in terms of area, it's always going to be looking at a quarter of the area to its left. All right, so Q1 has 1/4 to its left, 25%. Q2 has 2/4 to its left, 50%. And Q3 has 3/4 to its left, or 75%. Percentiles work very similar to this in that they do give you the area to the left, but instead of moving in quarters, they move in 1% increments. So very simply, if you're looking at a percentile, it is giving you the corresponding area to the left just as a percentage. So let's look at a quartile example. All right, if I want to find the z-score that corresponds to the first quartile, the first thing I want to do is put this in terms of area. And by definition, the first quartile has an area to the left of 25%. Now in decimal form, that means when I go to my standard normal table, I want to look for an area, it's already to the left, so I don't have to convert anything, of 0.2500. Now again, this is one of those cases where I can't pick or I can't find the exact area. So I'm going to get as close as I can, either 0.2483 or 0.2514. If I can find one that gets closer than the other, then I'm going to take that closest area, in this case 0.2514 gets a little bit closer, and then reading off the z-score that corresponds, I would have a z-score of negative 0.67. So it's the same process that you've been using. You just have to remember the definition of quartiles in terms of how they give you an area to the left. All right, now with percentiles, let's look at an example from our practice problems. Because like I said, they work similarly, but they go in 1% increments. So like in this example here, find the 65th percentile. So when I'm given a percentile that I want to find, again, the first thing I'm going to do with percentiles or quartiles is convert them to an area left. And since percentiles move in 1% increments, the 65th percentile just tells me I have an area to the left of 65%. That means I'm looking for a z-score where the area to the left is 0.6500. So I can take that to my table. This is more than half of the area, so it's going to be a positive z. And I want to get as close as I can to an area of 0.6500. So that's either going to be 0.6480 or 0.6517. Again, if you can pick one that gets closer than the other, that's the one you want to go with. So 0.6517 is getting just a little bit closer. And the z-score that corresponds is a 0.3 and 9 in the hundreds place. So again, these are areas of 65%. We found the z-score that corresponds, and that tells me the z-score that represents the 65th percentile is 0.39. All right, and remember, if you know the area left, you can also do these using Statcrunch. So I would go back to the standard calculator. Quartiles and percentiles are always defined in terms of what comes to the left, so they're always less than. If I want the first quartile, I can put in an area of 25%, 0.25, and there's my corresponding z-score of negative 0.67. If I want the 65th percentile, I can go right back to that area box, put in the area of 65%, 0.65, and when I hit compute, there's my z-score of 0.39. All right, so now go back to your practice, and you're going to have a good many questions in there where you're asked to find the z-score that corresponds to either a quartile or a percentile. And once you've got a good feel for that, then come back and watch my last video where we look at taking these methods and applying them to situations where the mean is not 0 and the standard deviation is not 1.